Okay, and the last bit to look at with 2D kinematics is what happens when the accelerations are not constant. So you should remember from kinematics the first time that we use DVA, displacement, velocity, acceleration. Displacement means where I am or how I've got from A to B, and the magnitude of that is the distance. Velocity means when I'm traveling, and the magnitude equals the speed. And well, acceleration means how fast am I speeding up or slowing down. So with vectors, it's going to be exactly the same. The only difference is we're going to have to differentiate or integrate each component of the vector separately. And if we have to integrate, remember the plus c, each component is only the plus c. So the particle starts from point P with velocity 3I plus j. And that was its velocity. Its acceleration is given by that. Show that the particle never returns to P. Okay, well, let's think about this thing for the minute. Let's ignore that question and let's see what we can work out from this. Well, we've got what A is. I'm going to write them as a column, so minus T, 2T. So we can work out B, remember DVA. So to get from A to B, we integrate. So remember, integrate each one separately. So V equals, well, minus T integrated at 1 to the power, divided by the power, so minus a half T squared, and 2T integrates to T squared. And now I need to add a constant, so I'm going to write it as a vector. Now to get the constant, they need to give us some information, and they have. It said a particle starts from the point P with velocity 3I plus j. So when t is 0, we know that v equals 3, 1. So we can sub that into here to find out what c is. So 3, 1. If we sub 0 into here, that's just 0 and 0. It won't always be 0, 0. So for example, if I had sines and causes or e's or ln's, it wouldn't necessarily give me 0, 0 for c. So therefore, my constant of integration is 3, 1. So therefore, v equals minus a half t squared plus 3, 1. Or I can write that as one column, so minus a half t squared plus 3 and t squared plus 1. So I've got its velocity, and it says, show that the particle never returns to P. Okay, so it's talking about where it is. So that means that we're going to need to do integration again to get displacement. So to get, we normally use the letter R for displacement, but it doesn't really matter if you prefer to use D or X or anything, but we usually use R. So R means we're going to integrate the velocity. So I'm sure you can remember to integrate, add 1 to the power. So 3t and divide by 3. So a half divided by 3 is a 6, minus 1 over 6 plus 3t. So a third t cubed plus t plus another constant. Don't really want to use the same letter c, so I'm just going to call it k this time. Okay, now it hasn't told me where the point P is, but since it's not asking me to work out saying to show that never returns to P, I can assume P is just any coordinate. So I'm going to use the easiest. I'm going to pretend P is just the origins of 0, 0. So therefore, I can say that R equals minus 6t cubed plus 3t and that. Yeah, and the reason for that as well, let's say that P was vector P. then what I'm going to do is show that the particle number returns to P. So therefore, I'm going to make this equal to P. So then the P's just cancel out anyway. So if returns to P, then the displacement equals 0. So let's have a look at what happens here. So this vector here equals 0. Then we get two equations. And this equation. Well, we could factorize both of them. We can, well, take T out. And we can take T out. So both of them give T equals 0 from the first bracket, which makes sense because it started at P. And then for the second one, I've got these two quadratics to solve. So I've got minus 1 over 6 T squared plus 3 equals 0. So minus 1 over 6 T squared equals minus 3. So T squared is 18. So T equals, well, plus or minus root 18, but it can't be minus. So therefore T equals root 18. And if we solve this one, we get 1 over 6 T squared plus 1 equals 0. So 1/3 T squared equals minus 1. T squared equals minus 3, which we know can't happen. So therefore, if T equals root 18, then this top one here equals 0, but the bottom one doesn't equal 0. The bottom one can never equal 0 apart from when T equals 0. This was kind of a tricky problem solving question. However, if you actually ignore that bit and just worked out B and D, then you would have got the majority of marks. Then just think returns to P means its displacement must be 0. But we'll talk about common phrases in a second. Okay, and one more. So a particle of mass 0.5 kilograms starts from rest and moves under the action of force 4t I plus 3t minus 2j n. Okay, so it's not constant, that force. That means the acceleration is not constant, so we can't use that. So we're going to find the speed and the direction of motion of the particle after 3 seconds. Okay, so we also know that t is 3 seconds, I guess. So we have, well, we're going to use F equals ma. So we have the force is 4t, 2t minus 2. We have mass is 0.5, and we don't have the acceleration yet. So we can find the acceleration using F equals ma. Knowing the vectors. So we have 4t, 2t minus 2 equals 0.5. Well, get rid of the 0.5 by dividing by it or just by times by 2. So 8t, 4t minus 4 equals air. Okay, so now I've got an expression for air. And remember, I can't use that, it's not constant. So that means I can use DVA. Let's talk about the speed. So I can use DVA. Well, I've got acceleration. So to go up to get velocity and speed, that means I'm going to integrate. So to get B, I'm going to integrate t 4t minus 4. So I get at integrates to t squared divided by 2 gives me 4. 4t goes to t squared divided by 2 gives me 2t squared equal to 4t plus a constant. Well, I know when it starts from rest, when t is 0, v is 0, 0. So therefore, well, that implies rather that 0, 0 equals, well, if I said 0 is there, I just get 0, 0 plus c. Therefore, c equals 0. Therefore, v just equals 4t squared, 2t squared minus 4t. Okay, so that's an expression for velocity, and I guess units on there. So after 3 seconds, I will get v equals 4 lots of 3 squared, 2 lots of 3 squared, takes away 4 lots of 3. So its velocity, that's 9, so that's 36. It's 9, that's 13. Take away 12, gives me 6. Okay, that's its velocity, but that's for speed. That's the magnitude, remember. So I'm going to do square root of 3 squared plus 6 squared, which is going to give me, actually I'm going to show you a trick, but from typing the calculator, I'm going to show you a trick of how to do this quickly. So I can factorize out a 6 from 36 and 6. So I can factorize out a 6 squared from both of them. So I'm left with 6 squared plus 1 squared. Well, 6 squared is 36, plus 1 squared is 1, so 36 and 1 is 37. And root 6 squared is 6, so 6 root 37. Just to show you that works. Square root 36 squared plus 6 squared, 6 root 37. Or if you wanted that as an approximation, 36.5 meters per second to 3 significant figures. And the direction of motion, well, motion means movement, and movement means velocity. Direction of motion means we're going to use v. So to see which way it's moving, well, we're going to use the vector 30. So this is what 36, 6. That means it's going to go 36 across, 6 up. So its direction of motion, well, I can either write it as a bearing or an angle above the horizontal. So I'm going to work this out. So I know that tan of the angle is the opposite over the adjacent. So the angle is tan minus 1, or arctan from 6 over 36. Make sure you're in degrees. So the angle is 9.463 significant figures. So the direction is 9.46 degrees above horizontal. But if you wanted to give it as a bearing, the bearing, you don't have to worry about all this above horizontal thing. Remember, bearing, you measure from the north line and you measure anti-clockwise, clockwise. So it will be this angle here, just 90 minus that. The bearing would be 90 minus that. So it would be 81, 081. We need 3 digits. Okay. And just a few common terms. Well, you can do all the SUAT bit, do all the DVA bit, you can do the F equals MA bit. The tricky bit is the problem solving bit, and that's where they use specific words. So we're going to try and work out what some of these mean. So we're going to suppose an object has position R1, R2, velocity V1, V2, acceleration A1, A2, when it times t, and we're going to see what these things mean in terms of these 4 components. So initially, that means t is 0. Well, at rest means there's no speed, so v1, v2 is 0, 0. At the origin, what that means, its position vector 0, 0. The distance from 1, 2, well, let's get its displacement from 1, 2. So it'll be R1, R2, take away 1, 2. So its displacement would be R1 take away 1, R2 take away 2, and then the distance would be the magnitude of that, so be root R1 minus 1 squared plus R2 minus 2 squared. Speed, well, that would just be the magnitude of velocity, which remember means root v1 squared plus v2 squared. Traveling due south, Well, traveling means speed. So if it's due south, that means it's that way. So there's 0 across and 1 down, so it's -1. So that means its velocity is equal to, well, it's not moving that way, and it's going down. Well, it might not be going down by -1, -2, -3, so it's equal to something times that. So I'm going to call it k, or you could write that as 0 minus k. Okay, we know it is due east of the origin, so talking about its position now, not travel, and its position is due east. Well, east, well, here's the origin, and it's due east, so it's over here somewhere. So that means its position, and I should have said here that k was bigger than 0. For this number here, it has to be positive. So here, it's went long by something, and it hasn't went up by anything, and again, it's times by a number, I don't know. So that could be k0. Well, again, k is bigger than 0, so it's went along by a certain number, and it hasn't went up. That's all that means. We just don't know what that number is. So for most time in these questions, it will be the fact that we know one of them is 0. We can solve that and get what t is, for example. Moving parallel to the I direction. Well, I direction is that way. Moving means velocity. So remember, parallel means scale multiple of that vector there. So I is 1, 0. So again, I can write that as k0. So its velocity is going so far this direction, north, not in that direction, northeast of the origin. So again, not traveling, this is its position this time, northeast of the origin. So northeast is that way. So its example could be -1 and 1, could be -2 and 2, -3 and 3, so minus k and k. So I can write it as R1, R2, it's k times -1, 1. I can write that as minus k, k. Okay, again, it's a positive number. And traveling northeast, so traveling means it's velocity this time. Northeast is that way, best place to come from. So 1, 1, 2, 2, 3, 3, k, k. So it's equal to k times 1, 1, so that's northeast, 1 across, 1 up, which is k, k. K is bigger than 0. Yeah, so make sure you understand all those if they'll ask me. And the last one, now suppose there's a second particle with position S1, S2, velocity V1, V2, and acceleration V1, V2. Traveling in parallel directions. Traveling means velocity. Parallel means, well, it doesn't mean that necessarily equal, but it means that scale multiples. So I times one of them by a number, I get the other one. Yeah, where k is a constant. And the objects collide. So that means R1, R2 equals S1, S2. The position vectors are the same, at the same place at the same time t. And if you can learn all those or spot all those, you should be able to do any exam question.